Hi, thank you for having me here. My name is Tobias Reiss. I'm working as a software developer for Xebu. And 1 year ago, we open sourced BonsaiJS, a graphics and animation library. And I think it's fair to ask, why yet another graphics and animation library? I mean, it feels to me there are tons of 2D, especially 2D graphics and animation libraries out there. Some claim to be really the fastest one in certain situations on certain platforms, certain browsers and dev mode. But I'm not going to compare performance today. It's more about the API and the architecture. I think that's, well, kind of unique. At least the architecture of BonsaiJS. But first, I want to introduce BonsaiJS a little bit. So it's written in JavaScript, not CoffeeScript or TypeScript or whatever script at all. It's written in JavaScript. It has an SVG renderer, also written by us. It's open source, yep, since 1 year. So feel free to contribute, feel free to file bugs or issues, whatever. Even so, we have tests and use it in production. The API is not finished yet. We still try to learn from our use cases and the use cases from the users from BonsaiJS. Yeah, and the website is bonsaijs.org. So you can, a lot of stuff with BonsaiJS. You can draw shapes. Shapes have attributes. You can apply filters like this drop shadow. You can animate your attributes. And the whole thing is to express your creativity, for example, to create infographics. Or to do maybe little games or educational software. Yeah, it is supposed to work, by the way. I don't know. That's good. No, whatever. The funny thing about that movie, by the way, is it's created in the Flash IDE. So how did that work? And that brings me to another product that is not open sourced. It's also from Xebu, and it's Pixelplant. And Pixelplant is a Flash to HTML5 converter. So by Flash, I mean SWF files. So we really take the raw binary. And yeah, so we convert ActionScript 2 as well as ActionScript 3. SWF 1 to 11, and Bonsai is the graphics library behind Pixelplant. So Pixelplant actually transforms the SWF to Bonsai code, and that's one reason. Also, one reason why we built it, because other graphic libraries didn't provide all the API we need to draw our Flash movies. And yeah, that's one reason why Bonsai is flavored with some API that looks similar to some Flash developer. You can find Pixelplant on pixelplant.com. Okay, let's dive into the API. Yeah, first of all, that's the entry point of every movie. It's Bonsai run, and you pass a DOM element. Yeah, we take the DOM element, place the movie there, we create a graphics context there, and the second parameter is the movie, of course. It can be a reference to a file. It can also be a function. We come to the reason why we don't apply drawing instructions on the constructor. I will tell about that right now. I think it's one of the smallest Bonsai scripts possible. In your Bonsai movie, you have a global stage object, and whatever you add to the stage is supposed to be drawn on your screen. And your movie runs in a sandbox. So what does that mean? That means that, yes, you have actually no access to the rest of your website. You don't have access to the DOM. But it allows us to take your movie and run it nearly wherever we want. So, for example, in an iframe, of course, okay, that's fair enough, but also in a WebWorker, for example. And of course, on the server, that would be possible as well. So, yes, we can execute your movie in these 3 environments and still able to draw your drawing instructions to the screen. And there is a way to communicate between your website, which I call the main thread, and your Bonsai code. There's API for that, and I will show you that a little bit later. First of all, I thought, okay, how can I show API? So let's play Pong. Okay, I create a little game, and by that I show you the API of Bonsai. First of all, I thought, okay, we need a background image, of course, the Reject.JS logo. So we simply create a new bitmap, and yeah, we add it to the stage, and that's it. So what's next? Okay, so we want to put it in the background, so I decide to apply filters. One is opacity, the other one is blur. The rest remains the same. We also have other filters as well. For example, Grayscale, or sepia, or Invert. There are others as well. Please have a look at the docs at docs.bonsai.js.org. Yeah, you can draw simple shapes. I use the Rect API to draw the petals for Pong, and the Circle API to draw the ball, fill them. There are more shapes. That's actually convenient API, right? So star, ellipse, polygon. We could add more. You, as a user, can add more via plugins. The generic object for drawing shapes is path. Is a path object. The cool thing about the path object is it takes SVG-like syntax and something you know from the Canvas API, the PostScript-like operators. So what does it mean? It means you can actually copy and paste your existing shapes to the path and pass it to the path object, and it is supposed to work. Okay, yeah, there's a color API, of course, but it's kind of rich, and it turns out it solves a communication problem between the designer and the developer. And by that I mean, in certain iterations, when the designer says, "Can you please take the following color?" and the developer says, "Okay, cool, I take it." And he says, well, it's not exactly the color I want. Can you please make it a little bit darker? Okay, now the developer says, well, couldn't you please just give me the color? And yeah, we can help. We have lighter, darker, and midpoint. Hey, what about midpoint? And if you just can't agree, you can also randomize. That's still possible. And that is very handy, especially for gradients, because you now can say, okay, my first color is blue, and my second color is also blue, but a little bit darker. And that makes a beautiful gradient, I think. Applied those gradients on the petals. Bonsai also supports gradients. Okay. Attre is the function we need to change any kind of attributes. So, for example, to change the position, we take x and y. Attre is also responsible for any other transformations, like scale or rotate. And it is also responsible for any styles, like colors, for example. Yeah, pointer events are built in, so that means we abstracted the pointer events for touch devices and for, I say it, mouse devices. That should work, and it works. Yep. So you listen to the stage. The stage is that what is drawn. So we abstracted that by the word stage, and then you can listen to those events like pointer move. Just to be able to show you the animation, especially non-linear animations, I decided to animate the ball. So whenever the game starts, the ball does like this. Cool. So the API looks maybe familiar to most of you because it's nothing new, also used by other graphic libraries. So you have a duration, you pass all your attributes you want to animate, and have some options to also change easing and stuff. We also have keyframe animations. That's nothing else. It's just an animation where you can decide to change the attributes at a certain time. But it's still all about changing attributes. And this is really just convenient API. It's, what we do inside is we change an attribute, which is path. So what you can do with morph tools, actually, you can switch from earth to ball by morphing all the shapes. Yep, this is the abstraction layer of set timeout or set interval or request animation frame. You can listen on the tick. You can listen on the tick event and place all your business logic within that callback. For example, yeah, I decided to write a plugin, and now we have walls and the ball. Yeah, I think we can play now, right? So I will do that just to prove it's possible. Yeah. Okay. Cool. Thank you very much. So, but I think it's much more fun if we would have sound. So the thing is, you create your sound and you add it to the stage as if it should be drawn. So that's the way we do it. And then when it's there and you can listen on the callback, like load, it's a callback, and you know, okay, it's available, and then you can play, pause, and play whatever you want. So I don't even need to play, and it still works. And I think that is very important regarding rich media. Come on. I think that's I think that's very important regarding rich media, and Flash movies are using this heavily. So I think that's a really cool feature. Okay, so now, as I said before, we need a way to communicate between the DOM and your Bonsai movie for several reasons. For example, if you want to listen on certain DOM events that are not available within Bonsai. What I did is I used the orientation API by the DOM, which allows me now to not use the arrow keys, but well, just my device. And now I can change X and Y and use it. And that's it's nice for this demo, but it's really nice for your touch devices. So this is about custom messages. It's also useful for those abstraction layers for your data you normally use to update your DOM. For example, AngularJS. That's also a way to update your movie when something happens within your main thread, within your website. Okay, I think the last thing I want to show you is the movie API. So who of you is Flash developer? Oh, okay. This is a JavaScript conference, so I think it would be okay if you, but okay. Whatever. So there's the movie API, and there's the display list, kind of an array, and it's really familiar to those Flash developers. And the cool thing is you can load asynchronously movies, which are nothing else than bonsai movies, which is a container, let's say a container for another movie, and you can load them within your bonsai movie. So this is a very simple example where we have a load an intro, and whenever the game Pong is completely loaded, we're going to get rid of that intro and start the game. So I destroy my intro and play the game. So to simulate this, I do it like click. So Oxibo presents is the intro, and bam. Okay, here we are. That's the game. That's one part of the movie API. There is a timeline, and you can specify the timeline by frames, by in percent, or I don't know, and seconds, of course. If you use percent, please don't forget to set the length of the movie clip, otherwise it wouldn't work. Okay, let's sum it up. We have display objects, path, bitmaps, we have text, we have audio, we also have experimental video, video support. That's the display objects. You can put display objects in, I come to it later. Display objects have attributes for changing the style and transform. And those attributes are animatable. You can put those display objects in display objects containers, which are a group. Very simple container, but you can also apply attributes on the container. And of course, the movie, which has a timeline for linear animation. Okay, let's go to the architecture. And you already know this, okay? So there is the renderer, okay, cool. And my script is executed in another environment. Yeah, we decided to give this a name. We call it runner, because it's not clear if we run it in a worker, in an iframe, or on the server. So we said, okay, runner. And between the renderer, which is supposed to be your website, your main thread, and the runner, there's of course a messaging protocol. And so we can send the drawing instructions from runner to the renderer, and events from renderer to the runner, and your custom messages, of course. And that looks like this. You use new path as an API. It is executed. We transform it to a drawing instruction. It looks like JSON at the moment. That's nothing you really supposed to touch, to be honest. And using an SVG renderer, it looks like this. You have SVG path. Yeah. Okay, one more reason why we do this. Because if you want to benefit from a WebWorker, for example, we think it could be faster regarding the frame budget. So what is the frame budget? The frame budget is the amount of time you have within your frame. And the frame could be maybe just 60 milliseconds. That's not much. And you do a lot of stuff in that 60 milliseconds. You have, for example, your timer, request animation frame, whatever, and other JavaScript stuff. You have a lot of painting, especially regarding an SVG renderer. And by painting, I mean layout, paint, compositing, styling. And you definitely need to compute the next frame. Yeah, and that's what I want to talk about. Oops. That's set. Yeah, thank you. I just want to talk about the next frame. So why are we doing this in the renderer? That's the question. Why don't we shift the computation of the next frame to another thread, which can be run side by side? So now we have much more time for painting. We can do more stuff. We can use the SVG renderer even longer. And, OK, that graphic is not actually completely fair. There's still some overhead by sending the data from the runner to the renderer. So, OK, let's put it like this. So we need to send the data, and we need to receive the data through the messaging channel. And then we can draw our drawing instructions. So that's another reason why we think our architecture makes sense. OK, let's go in a little bit into detail about the runner. I think most of the information are already clear. So what can the context be? WebWorker is used by default. So an iframe environment, I would choose the iframe environment while developing, because mostly the dev tools support of your browser is much better for an iframe than a WebWorker. I think Chrome does a quite good job. Even console log works now, but yeah, that's one point. But in production, I would say WebWorker is the choice. And yeah, Node, for example, with Socket.io, whatever. Yeah, you have one renderer per runner. Means whenever you say bonsai run, you actually spawn another WebWorker. But it's still possible to have multiple renderers, but just one runner. That's kind of interesting if you want to have a multiplayer game, for example. Then you just compute the next frame on the server, and you get all the information from the different devices, and send only the drawing instructions, nothing more, to the devices. Please don't expect me to claim this is really a good idea for, I don't know, Age of Empire or stuff like that. There are too many drawing instructions. But it should be really work very well with, for example, a ticker or something like Pong. I think that's fair enough. Okay, renderer. First of all, we are renderer agnostic. That's a big message, because we are able to exchange the renderer. So what we did is we wrote an SVG renderer, but we are able to take any other renderer out there, as long as the renderer understands our drawing instructions we send from the runner to the renderer. HTML5 is in work, mainly using CSS and HTML and Canvas and SVG and everything. Canvas, I would say near future, let's see. Also depends on how many people are contributing to the project. And, well, WebGL in the future. Please feel free to add an WebGL renderer. I would be happy. Why SVG? Yeah, okay, we love the SVG API. It's so rich. That's why there are so many bugs in the implementation, I think. It's just too rich. But it has all the API we need to be able to transform the Flash instructions to HTML5 instructions. Yeah, that's the thing about the SVG renderer. And we used it before, and yeah, we really like it. Okay, so let's sum it up. What are the benefits of BonsaiJS? Okay, we have the computation decoupled and logic decoupled from the actual drawing. We have one messaging protocol for. That's cool. I think what I want to say is we have just one messaging protocol, and we have multiple renderer. So we only need to let the renderer speak the protocol, and then we can use it. The renderer may block the main thread, but it is not supposed to block the runner when you run your movie in a worker, for example. That can happen for different reasons. For example, a lot of events, mouse events, touch events, whatever events. It's kind of a rich and simple API because we have been forced to support the minimum API to render all the Flash movies. And yeah, it's open source. So you can see the code, change it. You can also see the tests, which are the spec. Yeah. There's a list of links. I prepared Orbit BonsaiJS.org. This is where you can play around a little bit with BonsaiJS. It's an editor. On the left side, you see your script. On the right side, you see what's going to be drawn. And this is actually quite good to see a lot of example code. So we also have Orbit. Let's take group. No, don't go group. Is there a path? Yep. On the right side, you can also see the full documentation whenever you select something on the left side. We want to give a lot of example code. I think that's one of the most interesting parts when you're new to a library. You want to see example code, you want to execute something, you want to play with it. And that's what we tried with Orbit. So here a lot of example movies for a lot of use cases, audio and infographics and animations, some sweet pictures, and I can't scroll. I can scroll. Sometimes even we go into detail how we tried to implement Flash API. I think it's kind of interesting to just scroll through the list of example movies. And I would say, thank you very much. Please follow BonsaiJS for quite more informations. And that's it.